Hi, welcome to this session. This is ANT 324. Implement data access controls for multi-tenant Amazon EMR clusters. My name is Jia Liu. I am a Senior Product Manager on Amazon EMR. In this session, we'll briefly talk about single-tenancy, multi-tenancy, and the authorization challenges coming along with multi-tenancy. We will then dive deeper into the three data access control options: Amazon EMR User Role Mapper, Amazon EMR native integration with Apache Ranger, and Amazon EMR integration with AWS Lake Formation. We will conclude this session with a summary table comparing three different options. Single tenancy is built for resource isolation. Single tenancy means each user has its dedicated resources for storage and compute. With this setup, you do not have to worry about access control among multiple users. Multi-tenancy, on the contrary, allows multiple users to share the same set of resources. Multi-tenancy is usually used for cost optimization. Along with the cost optimization, there are authorization challenges. There are two types of authorization challenges with multi-tenancy on Amazon EMR. By default, all users on Amazon EMR share the same access to AWS resources, including S3 data. This is because Amazon EMR does not recognize the individual users submitting jobs. All users submitting jobs assume the same IAM role called EC2 instance profile, and they share the permissions defined under this IAM role. The second challenge on multi-tenant EMR clusters is we leverage AWS IAM permissions for these access control. This means you do not get fine-grained access control. In the context of Amazon S3, this means your access can only be controlled at the level of bucket, prefix, or object. We hear this feedback from our customers, and in the past year, we invested a lot in this area and come up with three different data access control options. Here is how these new access control options work at a high level. Amazon EMR built a process to intercept user requests so that instead of assuming the default IAM role, EC2 instance profile, users assume a customized IAM role depending on the access control option you choose. Your Amazon EMR admins can then define authorization policies and associate them with a customized IAM role. And Amazon EMR can use those policies to enforce data access control. There are two ways we can control Amazon S3 data. First, you can control access to Amazon S3 directly. This means you can define policies based on bucket, prefix, or object. Or you can control access to Amazon S3 data via metadata. This is also what we call as fine-grained access control. You can define permissions based on the level of databases, tables, columns, or even rows. Now let's talk about the first option you have with Amazon EMR for multi-tenant access control. Amazon EMR User Role Mapper, which also has a short name of URM, it allows you to create mappings between users groups and customized IAM roles. You can install and configure this via Bootstrap action, and your users will assume the customized IAM roles for scope-down permissions. There are a few benefits by using URM. URM is based on AWS IAM permissions, and because it is IAM permissions, you can control all AWS resources, including Amazon S3. you do not have to onboard a new service or set up a new server to control data access. It also allows dynamic mapping. This means you can change the mapping after you launch the EMR cluster. And lastly, you can also audit the access with AWS CloudTrail. With the above benefits, there are a few considerations before you enable URM. It is currently only available via AWS Labs, which is a GitHub repo managed by AWS. It currently only supports Spark and Hive, and there are some additional configurations required on Hive. For example, you need to enable user group mapping, and you need to enable authorizations like SQL standards-based authorization. It does not support PrestoSQL or PrestoDB currently. The second option is integration with Apache Ranger. For those of you who are not familiar with Apache Ranger, it is an open source tool that can be used to centralize your authorization policies. It works with multiple Hadoop applications, such as Hadoop and Hive. There are two key components to make Apache Ranger work with Hadoop applications. On the left side, you can see there's a policy repository. This is where you configure the permission policies for each applications, and you will have to configure these policies on the Apache Ranger admin server that you manage on your own. The second component is called Ranger plugins. Ranger plugins usually operate together with Hadoop applications. These Ranger plugins will sync up constantly with policy repository on admin server to make sure that when your user requests for access, they can be validated against these policies. Integrating with Apache Ranger means you can set up a new or bring an existing Apache Ranger admin server for centralized data access on EMR. The benefits by using Apache Ranger to manage your data access is Amazon EMR automatically installs and configures Ranger plugins instead of managing on your own. It authorizes Amazon S3 data at the prefix and object level. In addition, you can enforce fine-grained access control such as table level and column level policies for Spark and Hive applications to access the Hive metastore. And lastly, you can provide central auditing with AWS CloudWatch logs. Let's dive deeper into how Ranger plugin works. We have built two components, Amazon EMR components, into the Ranger plugin. The first is called Amazon EMR Secret Agent. Secret Agent is used to intercept user requests, identify the right IAM credentials, and manage temporary credentials for your data access. The second component is called Amazon EMR Record Server. EMR Record Server is designed to force Spark to delegate action of reading data, and it reads data and filters data before returning the data back to the user. This is how we protect your metadata from being directly accessed by Spark. With Ranger-Spark plugin, you can define policies at database and table and column level. One limitation with Spark Ranger plugin is Spark SQL access is on read-only today. We do not yet support write. Ranger-Hive plugin is similar to Spark plugin. For Hive plugin, we're using the same code that is provided by the open source community. This means you can bring your existing Hive policies with EMR Ranger-Hive plugin. In addition to database, table, column level policies, Ranger-Hive plugin allows you to define row level and data masking policies as well. The last Ranger plugin is called EMRFS. EMRFS plugin manages access to Amazon S3 via EMR file system. It is required as a minimum Apache Ranger configuration, and it allows you to define prefix level and object level authorization policies. One limitation to note here is we do not yet support S3 client-side encryption. Here's how you can configure the integration with Apache Ranger. There are two things you need to consider. One is the configuration on the Ranger admin server. The other is on Amazon EMR. First, you will need to set up the admin server, and then define the policies for each Hadoop application. On Amazon EMR, you can complete the configuration via console or API through security configuration. First, you need to establish a TLS connectivity between the Apache Ranger server and Amazon EMR Ranger plugins. We require you to leverage AWS Secrets Manager to store the secrets that is used to build TLS connectivity. You can then assign the right IAM roles and choose the AWS CloudWatch log group for auditing. There are two IAM roles you need to consider for integrating with Ranger. The first role is called IAM role for Apache Ranger. This is the role you can define all the privileges a trusted process can have when submitting Spark and Hive jobs. The second role is called IAM role for other AWS services. This means you can define the permissions for any access that you don't need Apache Ranger to protect. For security purpose, we do not recommend to grant this role any access to Amazon S3. Here are some considerations you want to be aware of before you begin this integration. Apache Ranger integration is currently only available on Amazon EMR 5.x version. It is compatible with Apache Ranger Admin Server 2.x. It supports Hive Metastore only, although we have planned to support Glue Metastore in short term. You can submit jobs via Apache Zeppelin, Hue, and SSH. It currently does not support Spark SQL for insert into or insert overwrite. It also does not yet support row-level filtering and data masking for Spark. Some major features we have planned to add in 2021 are Amazon EMR 6.x support, Glue metadata store support, and Presto SQL support. The last option you have with Amazon EMR multi-tenant access control is integrating with AWS Lake Formation. AWS Lake Formation is a fully managed AWS service. It discovers, catalogs, cleanses, and secures data in the Amazon S3 data lake. It works across multiple AWS analytics services, such as Athena, QuickSight, Redshift, Glue, EMR, and SageMaker. By integrating with AWS Lake Formation, you can define and manage corporate identity-based permissions in the AWS Lake Formation. And these permissions can be enforced on Spark users when they access the AWS Glue data catalog. The benefits of using Lake Formation integration is you have metadata protection with Spark applications because we have built Amazon EMR record server into it. By integrating with Lake Formation, you also enable federated single sign-on from your enterprise identity system. It allows you to define cross-account authorization. And lastly, it allows you to centralize your auditing with AWS CloudTrail. Here's a diagram showing how data access control works with Lake Formation enabled. First, when your user submits a job through the query engine, it requests access to the table. This request will be intercepted by Secret Agent and EMR Record Server. Secret Agent will talk to AWS Lake Formation to get short-term credentials for the table. AWS Lake Formation will return that credentials back to Record Server so that Record Server can use that to retrieve data from Amazon S3. Record Server will then filter this data and send back to the user. The configuration experience on AWS Lake Formation is very similar to Apache Ranger. On AWS Lake Formation, you need to create and manage table and column level permissions. You will then need to enable data filtering explicitly via the Lake Formation console. And if you need cross-account filtering, you will also need to enable that from Lake Formation side. On Amazon EMR, it is much simpler than Apache Ranger configuration. You only need to configure the IAM roles and specify the metadata of the identity provider. A little bit more about the IAM roles for Lake Formation. There are also two roles for Lake Formation integration. The first role is called IAM role for AWS Lake Formation. It defines the privileges for users accessing through identity provider. And the federated user should access Amazon S3 data only through Lake Formation. The other role is called IAM role for other AWS services. It can define the permissions for accessing non-AWS Lake Formation services. Here are some limitations and considerations for Lake Formation integration. It currently only supports EMR 5.x. It supports identity providers via SAML only. We currently only support AWS Glue Data Catalog, and there's no permissions to control S3 data directly. Currently, you can only use Spark with Lake Formation, and you can only submit jobs through Zeppelin and notebooks. We do not yet support Spark SQL for row-level filtering in writing into or creating a new table. The major features coming up in 2021 for Lake Formation integration is Amazon EMR 6.x support and Amazon EMR steps support. Here's a table that provides a comparison across the three different options. We hope this table gives you enough information to choose which option you should use. If you are looking for fine-grained data access control, we recommend Apache Ranger and Lake Formation. And there are some differences on the metadata usage across three options. For example, for URM, it supports all types of metastore, while Apache Ranger only supports Hive metastore today, and Lake Formation supports Glue Data Catalog only. URM allows both read and write into the metadata table, while Ranger and Lake Formation, both of them do not allow Spark SQL to write today. If you need direct access control on S3, we recommend to use URM or Apache Ranger. Lake Formation currently do not allow you to control S3 directly. Some common themes across three different options are they all operate on the latest or relatively new EMR 5.x releases. Kerberos is required for all three different options, and they all allow AWS service to audit, such as CloudWatch or CloudTrail. Currently, there are some differences on the query engines we support across three options. URM and Apache Ranger support both Apache Spark and Hive, while Lake Formation only support Spark. And URM do not care how you submit your jobs. And Ranger only allows Apache Zeppelin, Hue, and SSH, while Lake Formation supports Apache Zeppelin and EMR notebooks only. And lastly, only URM supports multi-master node, while the other two fine-grained access control options do not. This is the end of my session. Thank you so much for listening.